Yesterday we learned about independent events, and today we are going to learn about dependent events. So when the outcome of one event impacts the outcome of another, it is a dependent event. So read each situation below and determine if it is independent or dependent. So flipping two coins results in one landing on heads and one landing on tails. So when we flip one coin, we're going to land on heads or tails. And then if we flip the second coin, nothing's going to affect that from landing on heads or tails and having the same probability of a 50-50 chance. Therefore, this is independent. It doesn't depend on anything else. The captain of the football team is selected, and then the co-captain is selected. So once the captain of the team is selected, it takes him out of the running for the co-captains. So you have a group of people to select from for captain, but then you have one less person to select for co-captain because that one less person is the captain. Therefore, the co-captain depends on the selection of the captain. So this would be dependent. You draw a joker from a deck of cards, and then you draw an ace. So once we draw the joker, it didn't say that we put the joker back in the deck. Therefore, your deck is compromised because it has one less joker in it before we draw the ace. So it's not the same deck of cards. Therefore, this is dependent. You draw a queen from a deck of cards, replace it, and then draw a 10. Is this independent or dependent? Queen from the deck of cards, replace it, then draw a 10. This is independent. We learned this phrase yesterday. Anytime we say replace it, this means independent. Okay, and then a coin is flipped and the number cube is rolled. Independent or dependent? Coin is flipped and the number cube is rolled. So when I flip a coin, I'm going to get heads or tails, and then I'm going to roll a number cube. Does the number cube rely on the flipped coin? No, they're not the same thing, therefore they don't depend on each other. Therefore, this is independent. Okay, so here for independent yesterday, we learned that for probability A and B, we're going to take our probability of A and we're going to multiply it by the probability of B. So for dependent, for the probability of A and B, we're going to first take the probability of A. And then once our scenario is compromised because that first thing is done, then we're going to take the probability of B after A. So that means we'll have a new total on a lot of these. Okay, so let's look at this one. So if you remember this Neil problem number 6, we actually had the same problem yesterday with an independent scenario. So let's see how it's different. Neil goes to the pet shop and selects a treat for his dog. He chooses one and then he chooses another. What is the probability that Neil selects a bone and then a ball? So yesterday he put them back, right? So today he didn't. So we have a bone. What's the probability of a bone? Is 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7. So we have the probability of 3 out of 7. So we picked one of the bones. So that bone is now out. Okay, and so then it says a ball. So we have 1 or 2 balls. So we have a 2 out of a 1, 2, 3, 4, 5, 6 chance. Okay, so then we still cross multiply, and we get 3 times 2, which is 6, and 7 times 6, which is 42. And then we can simplify this by dividing by 6. 6 divided by 6 is 1, and 42 divided by 6 is 7. Okay, so we also had this candle question yesterday. Mackenzie chose one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot both times? Okay, so for polka dot, we have 2 polka dots out of 1, 2, 3, 4, 5 candles. So the first time Mackenzie picks, she has a 2 out of 5 chance of getting a polka dot. But the second time Mackenzie picks, this one is no longer in there. So now there's only 1 polka dot left. And instead of 5 candles, there's 1, 2, 3, 4 candles to select from. So we're going to multiply straight across. 2 times 1 is 2. 5 times 4 is 20. I can simplify by dividing by 2, and I get 2 divided by 2, which is 1, and 10 divided by 2, 20 divided by 2, which is 10. Okay. The back. So, what is the probability of selecting a top and then selecting a bottom? Selecting a top, then selecting a bottom. So let's count how many pieces we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 pieces here. And we have 1 top, right? So what is the probability of selecting a top? Well, it's 1 out of 16. So if we select this top, but then we're going to select a bottom. So we have 1, 2, 3, 4, 5 bottoms. So we're going to multiply it by 5 out of, we took the top away, so we don't have 16 articles of clothing. We now only have 15. Okay, so we're going to multiply straight across. 1 times 5 is 5, and 16 times 15. 5 times 6 is 30. 5 times 1 is 5. Plus 3 is 8. 0. 1 times 6 is 6. 1 times 5 is 5. 0, 8, 9, 10, 11, 12, 13, 14, 2. Because that's not 1 times 5. This should be a 1 right here. Sorry. 1 plus 1 is 2. Okay. So 240. So yes, we can simplify this by 5. 5 divided by 5 is 1. And then 5 goes into 240. 5 goes into 24 4 times. Minus 20. 4 left over. Bring down your 0. 5 goes into 40 8 times. Okay. So 48. Number 9. What is the probability of selecting a striped sock, replacing it, and then selecting another striped sock? Okay, so striped socks are obviously the ones with the stripes all the way down. The solid socks are going to be the ones with just the solid on the bottom. So the striped socks, we know that there's 16 in this selection. And I have 1, 2, 3, 4. I have 5. I have 5 striped socks. So what's the probability of selecting a striped sock? 5 out of 16. Now, let's say we picked this one the first round. So then when I go again, just kidding. I almost missed this, girl. It says replacing it. So if I replace it, then this actually is still there, right? Still my number one option. So I pulled it out and then I put it back in, which means all 5 of my socks are still there, which means all 16 pieces of article are still there. So this is independent. 5 out of 16. And I think they wanted us to identify. So put a dependent for the first one, or a D for dependent, an I for independent for this one. And then let's multiply straight across. 5 times 5 is 25. And then 16 times 16. 6 times 6 is 36. 6 times 1 is 6. Plus 3 is 9. 0. 1 times 6 is 6. And 1 times 1 is 1. 6, 15, 2. So 256. And that ends in a 5, and that ends in a 6. Therefore, it cannot be simplified. Okay, what is the probability of selecting a towel, replacing it? What does replacing it mean? It means that it is independent. So we're selecting a towel and then selecting another towel. Okay, so press pause, do this one on your own, and press play when you have finished. So there's only one towel here, so you have a 1 out of 16 chance of selecting it, and then you put it back and you still have a 1 out of 16 chance of selecting it. And we multiplied 16 times 16 on the previous problem. So what is the probability of selecting a skirt and a top, one choice after another? So a skirt and a top, one choice after another. Is this dependent or independent? It is dependent. Okay, so go ahead and press pause and try this one. Okay, so there are 2 skirts. So that's 2 out of 16. And then let's say we selected one of those 2 skirts. That means that that skirt goes away. And we now have 1 skirt left. And since one of the articles went away, we drop down to 15. So we multiply straight across, which is 2 over 16 times 15 we did in the first problem. It is 240. And then we can simplify this by dividing by 2. So 2 divided by 2 is 1, and 240 divided by 2 is 120. So you should have gotten 1 over 120. Okay, go ahead and press pause again and complete number 12. Okay, so go ahead and check this with someone near you and see if y'all got the right answer and talk about it if you did not. You should have plenty of time to do your homework. So go ahead and get started on your homework and use these notes. Submit your homework, submit your notes, and complete the answer document.